Okay, YouTube, I just want to look at in this last video a real life application of using some rational expressions and some maybe operations with rational expressions. So let's go ahead and take a look at what we have here. It says that the total annual amount I, and this is in millions of dollars of personal income earned in Alabama, and its annual population P in millions of people can be modeled by these two, I guess, expressions right here. And so we say that T represents the year and that T equals 1. We're going to have this correspond to the year 2001. So that is to say, like if T equals 5, then we would say then that would be the year 2005 and so on. So what we want to do is find a model M for the annual per capita income. And so when we talk about per capita, we mean like per person. And what we're going to do is use that model to estimate the income, in 2010. And so let's go ahead and start with this. The fact of the matter is this: if we know the amount of income, and this is our model for income, and we know the population model here, and they're both in terms of time, then what we could say is if we were to take the total income, okay, income, and divide by the people, the population, okay, what this would do is give us income per person, income per person. And what we do is we refer to this as per capita or per person income. So in terms of per capita income, what we're going to do is we're literally going to take our expression for I here and divide by P. And what they want us to do is write a model M that would model the situation. So let's go ahead and do this. We're actually going to take our I expression here. We're going to substitute this in. So we say our I function is 6922t, 6922 times time, plus 106,947. Now looking down here, we have 0.0063t plus 1. And all of this here, okay, is being divided by the population function, which is itself 0.0343t plus 4.432. So to do this, what I want to point out is essentially, yes, we are working with rational expressions here, and because we are dividing a rational expression by some polynomial expression, we will instead rewrite this as multiplied by the reciprocal. Now, if you are sad that we are not factoring the top and the bottom first and restricting the domain, then you're different, I would just say. And I still respect you, but in terms of not having to simplify here, it's okay that we don't simplify on this one because we're dealing with some pretty decimally values. So we get this right here times instead the reciprocal of our divisor, which is 1 over this 0.0343t plus 4.432. So as a matter of fact, we would say that this is our model as a function of time for per capita income. So what we were asked to do is kind of a follow-up to finding this model in the first place was actually go use the model to find the amount of money or income per person in a given year. And in this case, they say in 2010. So because 2010 corresponds to, excuse me, t equaling 10, that's precisely what we're going to do here. So the way this would look is, I guess I would write m of 10, or in other words, per capita income 10 years later would be our income model with 10 in it. So we'd say 10 here, plus 106,947, all over 0.0063 times t, which is 10. Okay, let me try to fix this here, plus 1. And then we're going to take this times 1 over 0.0343 times 10 plus 4.432. And so all we're going to need, of course, all we need is a calculator for this here. That is all we need. So we're going to go ahead and type this expression in. So I'll change my contrast here very quickly. So being careful how we type this in. As a matter of fact, what I'm going to do is I'm going to take everything on the left here. So starting with this, we say in parentheses, and then another parenthesis to quantify everything on the top, 6922 times 10 plus 106,947. There's our entire numerator expression, okay, divided by 0, in parentheses, okay, 0.0063 times 10 plus 1. So here, okay, is everything on top divided by everything on bottom, and all of that in parentheses. That's equivalent to this first expression here. What we're going to do is we're going to take all that times now 1 divided by this entire expression in the denominator here, 0.0343 343 times 10 plus 4.432. So end parenthesis, and I'm going to end the parenthesis again. So all of this quotient times all of this quotient here, what we end up with is 34707.07. So we get approximately 34707.07. And because this is income, we're going to go ahead and list this in I suppose, millions of dollars. So we would say, I guess this would be thousands here. It does say millions up top. But I think that in this case here, this 34707, unless I've typed anything in incorrectly, I believe that that would be what we get in our model. Cheers.